So we're going to do part 2 of the series here of just graphing a trig function. So here before me I have y equals 3 times the sine of 2 theta. And the first thing I just want to identify is my amplitude. Remember, the amplitude is the coefficient in front of the sine function, so here my amplitude is 3. So that means this graph is going to oscillate between 3 and negative 3. It's going to oscillate between 3 and negative 3. The second thing I want to figure out is the period, the length of the graph takes to repeat itself. So remember, this involves your period, this number right here in front of the theta. So remember, to find the period, we take, in radians, we would take 2 pi divided by that term, 2. So here my period would just be pi. My period would be pi. So the graph would repeat itself at pi, which is 180 degrees. So what I want to do is I want to first make my table of values. Now remember, to make your table of values, we'll figure out what increments we're going to go up by. And we figure out what increments we're going to go up by. We take our period and divide that by 4. So in this case we take pi and divide that by 4, and that can't be reduced, so we'll just go up by pi over 4 increments. So we'll start at 0, pi over 4, pi over 2, 3 pi over 4, and it should repeat itself at pi. So let's actually plug this in and see what happens. So we have to think about our unit circle at 0. And at 0, remember the sine function is the y value. So at this point, this is the point 1, 0. So at 0 radians, the y value is 0. So sine of 2 times 0, though, is still sine of 0, which still gives me 0. And 0 times this 3, 0 times 3 is still 0. So now let's jump to pi over 4. Well, pi over 4 is at 45 degrees, but remember, I'm taking it 2 times pi over 4. 2 times pi over 4 is 2 pi over 4, which reduces to pi over 2. And pi over 2 is one of those quadrantal angles right here. And the sine value right there is 1. So sine of 2 times pi over 4 is sine of pi over 2. Sine of pi over 2 is the value of 1. But 1 times 3 gives me 3. Pi over 2. So pi over 2 times 2, pi over 2 times 2 just leaves me with pi. Sine of pi, if I look over here, pi is right here, sine right here is 0. 0, if this all gives me 0, 0 times 3 gives me 0. Alright, now next one we'll try is 3 pi over 4. 3 pi over 4. 2 times 3 pi over 4 is 6 pi. 6 pi over 4 reduces to 3 pi over 2. And we know that 3 pi over 2 is down here, and the sine value is negative 1. So sine of 2 times 3 pi over 4 is really the sine of 3 pi over 2, and the sine of 3 pi over 2 is negative 1. But if all this equals negative 1, I take negative 1 times the 3. Negative 1 times 3 is a negative 3. And now this should bring me back to where I started at 0, but let's double check just to be sure. So at pi, I take 2 times pi. 2 times pi is right here on my unit circle. And the sine value is 0. And 0, if all that gives me 0, 0 times 3 is 0. So we'll make my graph 0, pi over 4, pi over 2, 3 pi over 4, and pi, and we can even go the opposite, negative pi over 4, negative pi over 2, and so on. So we'll graph my values. Let me grab another color. So at 0, we're at 0. Pi over 4, we're up at 3. At pi over 2, we're at 0. 3 pi over 4, negative 3. At pi, we're at 0. So we'll just draw the first oscillation here. And now it will continue in this pattern. So we could come up, down, up, and we'll just show it goes on forever and to the right, and also it's going to go on forever here. So here I can put my points in. It's going to follow a pattern. So there I have now graphed 3 times the sine of 2 theta. I've graphed that function, and that's it. So go ahead and finish your worksheet T10. You've got various cosine and sine functions in that sheet, and answer the questions on the very last page and see if you can't find what's happening with this b function and with this a function, and how do those really affect the graph.